My talk will focus on factory infrastructure monitoring and supervision. The outline of my talk, after a short introduction, I will talk about this topic, factory infrastructure monitoring and supervision, and our approach on this topic. After I show you a demonstration, and finally a quick summary. Introduction. So our company NETvisor is located in Budapest. It's an SME, a 20-year-old company with about 50 employees, mainly computer engineers. The annual revenue of our company is roughly 7 million euros. Basically, we focus on four areas, such as info communication, system integration, ICT operations, support systems, service management, support for design and development of broadband networks, and recently IoT Industry 4.0 system and service management. And this talk is related to that area. Okay, about factory infrastructure monitoring and supervision. So, industrial production environments are pretty complex. Basically, it consists of several subsystems, such as the production control subsystem, the ICT or communication subsystem, and the basic infrastructure, the facility. And the actual practice is that these subsystems are monitored and supervised individually and totally separately. Our approach is that to use unified monitoring and supervision, it is easy to implement a unified inventory of the factory infrastructure elements, to implement alarms and fault detections and determination, the source of a failure in case a failure happens. What are the benefits? Faster fault localization, decreased production downtime, and of course increased production capacity, and at the end, increased revenue. Infrastructure monitoring and supervision, how is that? Let's see in details. If we monitor in a unified manner these subsystems, the communications, the ICT subsystem, the production subsystem, and the facility, which means basically the power supply, then the fault manager builds an infrastructure and fault model and gathering alarms from these subsystems based on correlations and rules and purpose-driven data storage and handling. It determines easily and quickly the source of the failure using root cause analysis. Let me give you an example. If we have a power supply failure, for example, in the central communication switch, it impacts all the other subsystems of the factory. And in this case, the fault manager can be a big help to identify quickly the source of the failure. So what is the big picture? The factory infrastructure consists of the production and the production control subsystem, the ICT subsystem, and the base infrastructure, the facility. If we want to implement a monitoring and supervision system for this infrastructure, what we have to do? First, discover the infrastructure configuration and topology, and from this information to build a technical inventory and maintain this inventory, then monitor the normal operation of the factory infrastructure, and in case of failure, we have to implement a fault localization, which can be used to localize the real source of the failure. Of course, the collected failure data can be used for other purposes as well, such as for production planning and operation and maintenance purposes. But in this talk, the focus is on this middle part, so infrastructure monitoring and supervision. Of course, if we want to implement such a system, we have to have an appropriate communication infrastructure in place. So I just collected some requirements toward the network. So in case of monitoring and supervision, the operation is normal. You will see what I mean under normal later. The time scale is in the seconds to minutes time frame. The bandwidth is not critical, such as the delay and delay jitter. Rather, fault tolerance and security are critical factors. Synchronization is not critical, and the typical technology what is used is wired, but we have wireless alternatives or options as well, and some standards and protocols what are used, SNMP, MQTT, and so on. On the other hand, if we want to implement a production control system, these requirements are more challenging because the operation is real-time, not normal or not real-time. The time scale is rather in the microsecond to millisecond frame. The bandwidth is not critical, but the delay jitter, fault tolerance, security, and synchronization are critical factors here. The technology what is used is almost exclusively wire technology at the moment. And some examples for standards and protocols in this domain. This is basically due to the real-time operation. So we are using the Open Protocol Communications Foundation's unified architecture, time-sensitive networking standards, and another example, the Object Management Group's data distribution service for real-time services. So these are a couple of examples. Okay, what are our tools or approach to implement such a monitoring and supervision system? These are basically software tools, what we are using, and these are the products of our company, NETvisor. So for discovery, we have a tool called IP Explorer. For implementing inventory, we have a tool called NetInf. For monitoring, we have a very powerful monitoring tool called PerformanceVisor or PVSR. And for fault localization, we have been implementing a tool called FM or Fault Manager. So this is under implementation at the moment. Moreover, we have an IoT platform as well to facilitate the development of applications. It's called Sensor Hub, but as I mentioned earlier, we will focus on this part, on these four tools in this presentation only. Let me give you a short summary of these tools. IP Explorer, it's an automatic network discovery tool, a software tool. It implements vendor-independent device modeling, works together with arbitrary superior management, network management systems, and it supports network visualization and documenting. For technical inventory, we use the NetInf tool, which is a comprehensive inventory of ICT services and resources. It supports capacity and resource management, inventory visualization, daily operation, and failure recovery. For monitoring, we are using the NETvisor tool. It implements the definition and visualization of measurements and alarms. It shows a pretty good scalability, and it works together with arbitrary management tools and protocols, and it is also available on mobile devices. And the heart of the system, the fault manager, which is a fault or implements fault localization via root cause analysis. It builds the failure model based on correlations and rules. It implements alarm handling even for external alarms. So alarms not just coming from our NETvisor tool. It implements efficient data storage and handling using graph databases, and it works together with arbitrary management tools and protocols. And as I mentioned, it is still under development. Okay, to illustrate the problem and our approach, we have prepared a demonstrator. And the permanent version of this demonstrator has been implemented at the BME's Industry 4.0 Technology Center in Budapest. So this is the university's technology center. And the replica what we are using of this demonstrator, we are using this replica for giving demonstrations at conferences. The last occasion was at ACM SIGCOMM in August in Budapest. Okay, this demonstrator is basically a plotting board, a plotting table, which implements or illustrates the working of a bottling plant. The demonstrated production processes, case movement, bottle filling up, and case swap. The plant units are the warehouse, a self-driving cart, belt and tank, communication center, monitoring and supervision center, and an intervention console. However, this intervention console is not an integral part of the plant. Rather, we are using it to control the working of the demonstration. Okay, what is the normal operation? The cart moves the case with empty bottles to the belt from the warehouse. Imitating the belt, the cart travels through along the belt sides, while the bottles in the case are filled up from the tank whose liquid level drops. The cart moves the case with the filled up bottles back to the warehouse, where the filled up bottles are swapped with empty bottles. So this is the normal operation. How do we supervise the operation? Basically via measurements coming from our PVSR tool. We monitor the status of the plant unit and visualize it on the fault management console. So this is the screen of the fault management console and consists of the three subsystems: the production, the power supply, and the communication subsystems. And these boxes are the monitored components of the systems. The green means everything is okay, so everything works in the expected way. In case of failure, the fault management console shows the impact of the failure, if there is any. How? We can see that some of the boxes are colored in green. Green means there is a failure, there is an error with that box or that component. And yellow means that we have no real information, no real data about the status of the component. So we cannot say whether it works in a perfect way or it has a problem. And it visualizes the root of the failure. So the root of the failure, or the component which contains the root of the failure, will flash. on the console. Okay. So how the devices communicate? Basically via local Wi-Fi network, whose core component is this communication center. And all the other components and the sensors are connected to this core component, forming a star-like network topology. So it's a flat network, a pretty simple flat network. How does the failure get into the system? We have implemented two ways. The programmed way, so programmed failures, these are generated automatically from time to time, and we have implemented one failure per subsystem. This is to facilitate the unmanned working of the demonstrator. And there is another way, manually generated failures. These failures are ingested into the system via the intervention console. This is basically a tablet with this interface where you can see the failure buttons. And the failures can be ingested into the systems, into the system via these failure buttons. And it contains some other control functions as well to control the demo working. Furthermore, we have implemented Joker failure as well. You will see it soon. Okay, put together all the pieces, how we can ingest a failure into the system. So via the interactive intervention console, if we just touch on one of the failure buttons, the failure will be ingested into the system right one in real time. The normal operation on the demo table will be interrupted. And on the fault management console, we will see the impact of the failure and the root cause of the failure as well. Moreover, we have implemented a notification service as well. So on the operator's mobile device, a message will appear containing the source of the failure. So first an error message, and a confirmation message after the recovery from the failure. Okay, so that's all. And we made a promotion video just for you, so it's still hot. You will be the first to watch it. If we can start it, hopefully, yes. That guy is me. Okay, that was it. So, summary. For factory infrastructure monitoring and supervision, our approach is to have a unified monitoring solution which monitors all the subsystems in a unified manner. Our solution builds on four software tools, namely the IP Explorer for discovery, the NETIM for technical inventory, the PVSR tool for performance monitoring, and the Fault Manager tool for fault localization. And we prepared the demonstrator to illustrate our approach via bottling plant factory. Okay, we have a couple of partial full reference deployments as well. I just collected some of them. So at the Richter Gideon PLC, it's a pharmaceutical factory in Hungary. We have deployed the Internet IP Explorer and the PVSR tool. At the Borg Warner Ltd, it's a car parts supplier factory in Hungary. Similarly, we have deployed the IP Explorer and PVSR tool. And at Suez Water Ltd, we have all the four tools deployed, and basically this is the pilot for the Fault Manager. The slide contains some more details about these deployments. Future. Of course, it is not easy to predict the future in this domain, in this industry 4.0 domain. However, I'll try to collect some thoughts. It seems we cannot avoid the mass deployment of sensors and IoT devices in factories. Furthermore, big data analysis will gain more and more attention to support decision-making, optimization, and maintenance, for example, predictive maintenance, such applications. Powerful real-time applications will come in production control as well, and nice and interesting virtual reality and augmented reality applications will appear to assist daily work. We heard a couple of examples in the previous presentations for this virtual reality area, and it comes into the industry field as well. I have to say that the development of our Fault Manager and the demonstrator has been supported by the National Research, Development and Innovation Office of Hungary, so many thanks for it. And this concludes my presentation. Thank you for your attention.
Thank you. Are there any questions? Can you go to the microphone, please? Behind you.
Richard from Huawei Technologies. So I have questions. Actually, it's no question, just get your opinion. So you mentioned time-sensitive networks and for the industry for all in factory. So, but that protocol is a layer 2 protocol, and probably it's only applicable to a small area. So for your work, do you have any use case so that would connect different sites or different factories? Maybe in a factory you have different shops there, so workshops there. So when you connect them, so which kind of protocol do you think that might be best? Do you also think that TSN can still be used there, or is there any other alternative option?
Yeah, thanks for the question. Well, as I mentioned, these are two different areas. So monitoring and supervision of the infrastructure is one area, and production control is another area. And for the monitoring and supervision task, we don't have really strict requirements toward the network. So of course we have multi-site deployments as well, and we can use internet or any other solution to connect the sites. So for the monitoring purposes, it's not critical. For production control, I'm not sure this time-sensitive networking approach can be adopted for multi-site communications or multi-site production control, or at least it needs some dedicated environment or resources.
Yeah, I guess it would, because TSN's a layer 2
Yep.
Technology, isn't it?
Hi, James Crawshaw from Heavy Reading. You mentioned that you use Wi-Fi to connect the various endpoints inside the factory, and yet the telecom industry is very excited about the potential for 5G to be used to connect those endpoints. So I was curious, it was absent from your presentation. I guess it's not been deployed yet, but do you think that 5G is worthwhile replacing Wi-Fi with 5G in factories?
Yeah, definitely. This is the right way to go. Just to make me clear, the Wi-Fi technology was used to build the demonstrator. So not in real deployment. We just used Wi-Fi to build the demonstrator. Okay, because this was the easiest and achievable technology for us to implement the demonstration. In production environment, Wi-Fi is not an option, definitely. So the propagation performance is not so good for the Wi-Fi technology. And as I mentioned, in production environment in factories, the most dominant technology still today what is used is wire technology. And they are looking for some wireless alternatives, but definitely not Wi-Fi. Okay, thanks.
Any more questions? Then we have the coffee break now, and we start again at 11, I think. Okay.
Thanks.